It is given that a ball is moving with constant speed in a horizontal circular path. And the first question is, draw and label arrows to represent the forces on the ball in the position shown. What forces act on the ball? It's gravitational force or weight, it downwards, mg or capital W, and tension. Tension is along the string upward, capital T. And notice that there are only two forces, no more forces. State and explain whether the ball is in equilibrium. In equilibrium implies the net force is equal to zero. It means forces are balanced in any direction. And when a ball is moving in a circular path, these two forces never cancel each other. Hence there is non-zero net force, so it's not in equilibrium. Or since direction changes, velocity changes, hence there is acceleration, and hence there is net force, so it's not in equilibrium. The next, determine the speed of rotation of the ball. And let's consider the resultant force. It's the vector sum of these two forces, and since it's the sum of two vectors, we should apply a rule for the sum of two vectors, and we can apply parallelogram rule for the sum. So we draw a parallelogram, and a diagonal is the resultant vector, and it's the resultant force. It's the sum of these two forces. It's equivalent. We can consider this force instead of these two forces. It's not the third force, it's the resultant force. It's the sum or equivalent of these two forces. And we know that if it is moving in a circular path, the resultant force is always to the center. And since it's a horizontal circle, the resultant force is and must be horizontal. And notice that when we draw a force, this length represents the magnitude of the force. And if you draw like this, and when you draw a parallelogram, you can see that resultant force is not horizontal, it's not correct. So you should draw such length so that the resultant force must be to the center, must be horizontal. And it is given in a data booklet that for the circular motion, the resultant force is ma, and it's mv squared over radius, and hence the magnitude of this vector is mv squared over radius, and hence we can consider such triangle, which is a right angle triangle, because mg is vertical, resultant force is horizontal, and this leg is mg because the magnitude of this vector is mg, and hypotenuse it's tension because the magnitude of this vector is t, and it's the resultant force, which is mv squared over r. And we can see that 30 is here and also 30 is here, and to connect any two values in this triangle, we can use sine, cosine, or tangent. And since we need v, we can consider tangent of 30 degrees and its opposite leg over adjacent, so it becomes mv squared over r over mg, m cancels, and hence we get that v is square root of rg tangent of 30 degrees, and it can be easily calculated, and finally it's 1.4 meters per second. Another way to solve this problem, it's to use in general the second Newton's law. F is ma, where m is the vector sum of two forces, so the second Newton's law, F is ma. F is tension plus a vector plus mg vector is ma vector. Acceleration is to the center. And we choose coordinate system. Let x be horizontal to the right, y be vertical up, and we rewrite this vector equation in components. It's called in projection on x-axis and y-axis. And 30 is here, and 30 is also here, and this angle is 60. So component of t on x-axis, it's this leg, and if we consider a right angle triangle, we can see hypotenuse, it's the magnitude of a vector, it's t, and we need this distance. So it's t cosine of 60, and it's plus because it's in the same direction as x. So component of t in x direction, it's t cosine 60. mg is perpendicular to x-axis, so its component is 0 and is equal to m, and component of a is parallel to x and in the same direction, so it's just ma. A is given in a data booklet, it's v squared over r. And let's consider, and we can see that there are two unknown variables, t and v, so we cannot calculate v from this equation, so we need another equation, and we can get it if we consider this equation, vector equation, in projection on y-axis. So it becomes component of t on y-axis, hypotenuse, it's the magnitude of this force, it's t, and we need opposite leg, so it's sine 60. So it becomes t multiplied by sine of 60. mg is parallel but in opposite direction, so minus mg is equal to 0. Or we can move mg to the right, and it becomes t sine of 60 is equal to mg. And since we need v, we can divide both sides and get cotangent. Cosine over sine is cotangent of 60, or 1 over tangent of 60, it doesn't matter. Let it be 1 over tangent of 60 is equal to mv squared over r divided by mg. M cancels, and we get that v is square root of rg divided by tangent of 60. Multiplied by tangent of 30 is the same as divided by tangent of 60, so we get the same result, it's 1.4 meters per second. And that's all for this question.